Welcome back, where we are discussing how to further classify polygons. At the bottom of your journal, so leave a big open space for us to glue in that portion of the workbook later. At the bottom of your journal, I want you to write this phrase: polygons can either be blank or blank. Make sure you get the blue color there, the purple color here, and then a green arrow to the side. So we're going to take what we know about polygons now. We know they're two-dimensional. We know they have to be line segments only, no curves. We know that the lines cannot cross. And we know that it has to be, well, I already said all those two-dimensional. So that's all we need to know about polygons. Now we're going to take a look at some polygons and decide whether or not they are concave or convex. Those are two new vocabulary words that you learn in 5th grade when it comes to geometry. So polygons can either be concave or convex. Okay, to be concave, we're going to learn a little bit more about what it means to be concave on the next page, and you're going to learn a little bit more about what it means to be convex on the next page as well. So what we're going to do is turn our journal page, and we're going to split that journal into two little portions, kind of like a T-chart, but not all the way down, just a little bit like this. So we're going to have concave on this side and convex on this side. We're going to draw a line down the middle, probably only like to the hole in the middle. So that'll be the T-chart, convex or concave. Do the green line down the middle because they're all going to be polygons. Concave was blue, and convex is purple. Okay, we have concave and convex. You can see on your workbook page, you should still have that out to the side. You can see they give a pretty good definition of it. It says a polygon is a concave polygon if you can connect 2 points inside the polygon with a line segment that passes outside the polygon. So that can be a little confusing. I definitely think that definition is a little confusing. So one way I like to think of this is about a shape being the cave because of the word concave. And if we connect 2 points anywhere in the shape and we can get it to go outside of the cave, then we consider it concave. Okay, so without cave, or it goes outside of the cave. So we're going to put kind of what the book definition says, but use some a little bit more familiar words. We're going to say if you can connect 2 points inside the polygon. So just think of it right now as drawing 2 different points inside of the shape, and the line segment, so you would connect those 2 points, right, to make your own line segment, and the line segment goes outside of the shape or cave. Outside if it goes outside of the shape or cave, then it is concave. Okay, so it has to go outside. You can make that like a sun, a blue sun. And then we're just going to remember cave. That's how we're going to remember that it's a concave, if it goes outside of the cave. So let me give you an example of this. Let's just go ahead and draw one of these polygon shapes from before. That would be concave. Utah would be a concave shape. So we're going to draw the shape Utah. That wasn't the best example of Utah, but that's okay. We're going to draw it blue because I know that this is going to be concave. So I want you to follow what the directions say for concave and see if you can figure it out. So find a spot where you could put 2 points, and when you connected those 2 points, the line went outside of the shape. So like if I put a point right here, here and here, right? That doesn't go outside of the shape. That stays in. But watch this. If I put a point here and here, and I connect those, see how it went outside of the shape right there? So that is concave. It only has to be able to do that once, and once it does, it is automatically considered concave. Another shape might be, if you have a shape that looks like this, and comes straight and straight. Well, I guess I should keep that a straight line and not a curve. And then it goes in and back out. Kind of like a square Pac-Man looking shape. This would also be concave, because you can tell I could put a point near those parts that are going in. So let me give you an example. I could put a point here and here, and when I connect them, it goes outside of the shape, right there, right? Or I could do it on the two corners, and it would also go outside of the shape. I think an easier way to remember this, and I actually was just working with a good family friend who's in 9th grade, and they were going over this with their online school as well, and I thought it was super interesting. Her teacher actually, a trick or a way to remember it, I thought this was so cool. She thought of it as, instead of doing the 2 points, you can, let's give you some other tips and advice from other teachers. If you were to put a rubber band around the outside of the shape. So if you stretched, that is definitely not how you spell is it stretched? I don't know. I think it is TCH. Oh my gosh, are you just loving this so much? Nothing is going to help you feel like you're more in class than Miss Fisher's spelling. So if you stretched a rubber band around the outside of the shape, and it doesn't fit snugly or perfectly around, then it is concave. That is what her teacher told her. So it's like taking a rubber band, if I had a rubber band, and stretching it around this shape. Think about it. If I let go of the rubber band, it's going to be on the outside, outside, outside. But then what would it do? What would the rubber band do from this point to that point? It's not going to automatically go in. It's going to stretch. And there's going to be this weird gap right there. So it wouldn't fit snugly around the shape Utah. Therefore, it is concave. So think about it this way again. If I put a rubber band around this shape, I wish I had a rubber band handy, but it'd be hard because the shapes are two-dimensional. But if I had a rubber band and I stretched it around here, it would go perfectly along that straight line. Perfectly, perfectly. And then what would happen from this corner to that corner? The rubber band's not going to by itself go in. The rubber band's going to stretch from corner to corner, and there's going to be this huge gap right there. So I thought that was pretty interesting. In fact, it might be worth us taking a different color. Like maybe we could find a yellow and pretend that's a rubber band. I think that would be cool to show what would happen here. Well, yellow might be a little tricky just because it's going to bleed into the color, but that's okay. All right, so if I had a rubber band and I stretched it around here, it would go around the straight parts, it would go around the top, and then what would the rubber band do? It would stretch from that corner to that corner. So that's where there would be a problem, right? Same thing here. It would go around the flats, it would fit perfectly right here along the bottom and the top, and then what would it do here if you're not anchoring it to that point? It's going to go straight down. That's what the rubber band would do. So that's how you know, in that teacher's description, that's how you know it's concave, if the rubber band doesn't fit perfectly around the shape. So I thought that was really cool. That's different than how I've ever taught that, but it's always good to have a different perspective. I've always taught it the way where if you have 2 points and it can go outside of the shape at all, then it goes out of the cave and it's concave. You can think of it as like a rubber band right, that doesn't fit perfectly around the cave, then that will help you remember that it's concave, that it does not fit perfectly around the cave. Hopefully that makes sense. In the next video, we'll explore more about the other types of shapes called convex shapes.